I can go back up to my view options and click on display node values, and it'll show me the base demands. All right, so next step, we got to put our pump in. So I'm going to go up to add pump. The left three things on here, the junction, the reservoir, and the tank, are all kind of behave like a node or like a junction. The right three things, the pipe, the pump, and the valve, all sort of behave more like a link. So when I do the pump, I don't just plop it down. I have to draw it from one junction to another. And so I'm going to click here and draw it like that. And you can see that in the direction I drew the pump, its little outlet nozzle is facing in that direction. If I right-click on that, actually go back up to my black arrow, right-click on it. If I hit reverse, now it's going the other way and the outlet nozzle is going to the left. So this is the one place where, for your project, this is going to be important too, that you need to have your pump facing the right direction because it will pump in the direction it's facing. If I have it facing like this, it's going to want to be pumping from the tank into the reservoir, which is really bad because the reservoir is so low compared to everything else that it's going to basically vacuum pressure the whole system and drain it all out. That's bad. So I want to go back and reverse it so it's going the other way. Okay, so I need a pump curve so that the system knows how to handle this pump. So the way I'm going to do that is I go back up to my browser up here in the upper left. I'm going to go to Data, the Data tab. By the way, in the Data tab, I can select different things, like I can select junctions, and it'll list all my junctions here. And as I click through them, it'll show me where it is on the map, and it'll update the properties, so I can kind of go through and click them that way. Same thing with pipes. But right now I want to go down to the option that says curves. And I'm going to hit this little button on the bottom of the browser that says add. And I get a little curve editor. And this allows me to enter in different flow and head points to define what the pump curve looks like. So with a real pump from a catalog, I would look at the pump curve and I'd take a bunch of points off it and I'd keep adding them to this table, and it would keep updating the pump curve so that EPANET knows how the pump behaves. In this case, I'm defining my pump with a standard design point of H equals 150 feet and Q equals 63 GPM. So type in for flow in the table 63 and for head 150, and then just kind of click somewhere else in the table, and you'll see it draw this this graph, and then it's defining this equation up here to define that curve. So what it's doing is it's taking whatever value I put in the flow, it's doubling it, and that's making that the x-intercept. So 63 times 2 is 126. That's where this curve is intercepting here. It's taking whatever I put for the head, which is 150. It's multiplying it by 1.33, and it's defining that as the y-intercept. So in this case, that's 200. And then it's making a quadratic equation to connect those 2 points. So if I only put in one head point here, that's what it's going to do. So in your project, you're going to be designing a pump to meet the specs of your system. And you need to know how it's going to draw the pump curve, because you're going to be designing things like, where do I want this point to be? Where do I want this point to be? In order to know in order to know what to put in this table, you need to know how it's handling that single design point. And it's handling it by 1.33 times the head is the y-intercept, 2 times the float is the x-intercept. My curve ID, I can rename it. I'm just going to call it 1. I'm going to hit OK. And now I have a curve. So now I go back to my pump, bring up its properties, and under pump curve, I'm just going to press 1. If I had renamed the pump curve as like pump 5, I would type in pump 5 here, so it pulls that curve. And that's all I'm going to do for this pump. There's a lot of other things I can specify, but that's all I'm going to do right now. And I think I've done everything for the base case. So I'm going to see if I did this right by running the simulation. And as soon after I've run it once, I'll go back and I'll put in the fire. So the way to run this thing, there's a little lightning bolt up here that has run, or I can go under project and go down to run analysis. So let's hit the lightning bolt. Mine says run was successful. Yours may have given you an error if you did something wrong. Does anyone have an error? Yeah. Few people. What does your error say? Okay.
Negative pressure.
Negative pressure. Warning messages. So if warning messages were generated, just hit OK. It'll bring up a little kind of notepad of the different stuff it saw. You can try to interpret what it's saying to get an idea of what was wrong. It might give you a node ID or something like that. It might say negative pressures. You might need to go and figure out, are your is everything in the right place? It's possible too with these two nodes. You want to make sure they don't have a base demand, and it wouldn't hurt to put those at a 0 elevation. It shouldn't matter too much, but neither of these two should, no. Let's go through the different view options here now that we have an analysis that's done. There's a lot of different ways I can view results. One of the easiest ways is just to go back up to my browser to the map. And for nodes and links, I could say for nodes, I want to look at, say, pressure. And for links, I want to see flow. And also another thing I can do is if I go back up to my view and I go to my options, there's an option for flow arrows that I really like to have on. So pick either open, filled, or fancy. Fancy, the little flow arrow is slightly curved. If you zoom way in on it. Maybe not. I don't know. All right. So now I have all my pressures at my nodes. The pressures are in PSI. So I can see these green nodes up here, 54 PSI. About the same through most of the whole system. My flows, I can see where the flow's going and how it's splitting. These flows are in GPM. Now the